Hey, how's it going, guys? So here we are, just a little update for Open-FDD. This is still a weekend hobby project, but just kind of getting some interesting use cases, mostly inspired by OpenClaw. I was using OpenClaw a little bit just to see if that agentic AI processes could help me. Then I got inspired by a couple other projects that actually borrow the use cases of OpenClaw into their own project. So I'm kind of marching down that path of picking all the cool pieces out of OpenClaw for just anything that you might need that is useful for smart buildings in fault detection, data cleaning. Is also a huge helper here, defining fault rules and AI assisted data modeling. So just kind of pick out, we only need like a few super cool use cases, but perhaps not the entire complexity of OpenClaw. It is kind of can be daunting to set up. It's not easy. It's kind of known for that too, and there's so many features of OpenClaw. Like at least I don't need to like have the ability for Telegram chat interfaces, Discord bots, and so it has a lot of like integration features to chat with it in like a rich subset for agentic AI processes. But for me, I think with fault detection, if I'm doing a lot of data cleaning, if I'm doing a lot of help me set up a data model, I don't need like 10 agents running all night long, which some people demo on YouTube, like what they're doing with OpenClaw. So I basically just kind of picked out some pieces of OpenClaw and put it right into Open-FDD. So here's Open-FDD right at the moment. So right at the moment, this is just a desktop application. It's kind of bare bones. It's still a web app running behind the scenes, but it's just meant to be a local web app that you run. It's not to be exposed to the internet or anything. It could work in some kind of like behind the firewall environment. Let's say you have an office and you want to spin up a dashboard for other people to use. Perhaps something like that. It could be just like some kind of tool that I just run it locally right on my Windows computer here, the same one that I'm recording this YouTube video on, and so I think it's kind of going down that direction at the moment. And there's no Docker. It's really simplified. There's no Docker. There's no database. I am using storing data in Feather format, which is something from Apache Arrow. It's like an optimized data storage format, which is used kind of heavily in the Python and R programmers for analyst workflow. Like a Python programmer and an R programmer can actually exchange data through Feather. It's actually a compiled binary of just data. So it's an analyst format for basically doing heavy data lifts, optimized data storage and querying without like the heavy lift of a database. So at least for me, I'm kind of just in the analyst mode of like I retrieve data from a building perhaps, and I just run all my tools and I kind of find everything that I need out of the data, from CSV files or whatever that I have available. So I don't really need like an optimized database, that might be more associated in IoT. I'm just doing like kind of analyst work here, local analyst work, which is typically done just locally right on your computer. So let me just give you an example of this workflow. Hopefully it'll work. So this is Grafana. Everyone knows Grafana. So I have an air handling unit, just typical variable volume air handling unit. These might be hard to see, but supply air static pressure, supply fan command, outside air damper, air handling unit, sensors for return air temp, outside air temp, average space temp, mixed temps, coil, heating coil, leaving temp, heating coil valve, cooling coil valve positions, fan statuses. It's pretty common something that you'd see in air handling unit systems. So this is also 90 days of data in Grafana. Lots of big mess here on the time series. So I'm just going to go to inspect data, and then I'm going to download for CSV, download for Excel. So, and if you notice this already, it includes like this. So the timestamp is optimized 15-minute data, just whatever that's coming from this building automation system is what it is. That's all I have. So what I want to try and demonstrate is using this CSV file with these kind of unwanted characters. You see the degrees Fahrenheit, and then this true fan status is just a true, lowercase true. So I think I need to change that into a 1 or a 0. Percentage is also included in, which kind of stinks. So there's a big data cleaning mess here. So someone in the olden days, someone would have to make a script usually in Python in the Pandas world, and actually strip all these unwanted elements out of the columns to make plots, and then to get useful metrics, and then to do analytics. You also can't have these unwanted characters in the data, so the data's messy. Okay, so I'm just going to download this CSV. Okay, so I downloaded the CSV points histories from Grafana. I'm just going to give this just say a site. So this is for brick data modeling. This will be pulled into that. So I'm just going to call it testing 1, 2, 3. Give it a site. Boom. Here we go. Here's some drivers. So this will be future. I don't have this ready yet, but someday we'll be able to ingest SpecNet data. I want to do this in the future. The folks at Onboarddata, they have some sample buildings too, Sandbox buildings, to make a driver for these guys too. So you could actually pull data from their API and do all the same thing I'll demonstrate with a CSV file. So, excuse me. So basically you could bulk download data from Onboard. Also this is weather from OpenMedio API. That's a historical weather API that's free. Perhaps we can build another one for normal framework, or Ace IoT cloud, whatever. If people request it, we can build this. It's just some Python code that runs in the background, and it can pull down bulk amounts of data that you could run locally here. Same thing with the CSV file. Okay, so I'm just going to go to the CSV file import tab. Scroll to my downloads. Here's my file. Okay, so it parsed all of this information right out of the box. What do we got here? So if you see this data, it's like really messy. It's including inches water column right into the data here, percent sign. Pretty messy, but we have it parsed it okay. So that is fine. This is what it looks like on each row of the data. We get a timestamp, and these will be columns. So next I'm going to jump right down to fault detection rules. So we can also, you can load, okay, so this is comes to the expression Rule Cookbook. This is something that the AI agent under the hood here also has access to all this in model context format. So it can look at this low duct static pressure for fan at full speed. So this is this will be a useful rule in this variable volume air handling unit. And then this is actually the rule that's it's in Python NumPy library format. Pretty basic stuff here. So like if the supply fan static pressure is less than the supply fan static set point minus some kind of error factor, and the fan is at full speed, that's a fault on that row of data. Here's some air blending. So sensors should kind of have equal, usually in variable volume air handling unit systems, these sensors should kind of equalize each other at certain times. When the free cooling happens, like we're in now, it's shoulder season, so air handling should be using free cooling. And when the damper is at 100% open, in theory, the return temperature from the building should equal the mixed air temperature, because the air handler is 100% outside air mode. And there's also some fudge factor for fan heat that's usually included with this. They're calling it blending tolerances. So I think you get the point. There's a whole bunch of rules here that are also in the model context that I'm going to see if the AI agent can create some cool rules for a variable volume air handling unit, and then also clean the data at the same time. Okay, so I'm just going to, you can mass upload YAML files yourself, which I think I do have some. Actually, I might have deleted them. So you can upload them one at a time. You can delete and edit them. You can, so you can do that all through the browser here. I might also, on my other YouTube channel for the BACnet Stacks Playground, is demonstrate some, we're vibe coding a building automation system, like actually vibe coding a building automation system, something really bare bones and like concepts idea. It's just a concept idea for fun, to play around with how good is AI at making like a really dirt simple web app, and playing around with some BACnet scripts. It's mostly just for learning purposes and a little bit about full stack software engineering. Then we're also doing some basic Python programming, a little bit of computer science 101. So it's really good for people like me that have mostly 10 years experience as a building automation field technician, and then maybe a little bit of retro commissioning experience. People that are like really heavy field experience, know how the ins and out of building automation. I'm kind of relating it a lot to being a car mechanic that could be deep into engine grease and transmission oil. But if you were like a building automation technician, like I was, you were deep into wire nuts and relays and valves and dampers and cabling and, whatever, climbing ladders, so you're kind of like at that level playing around with web apps. And, like I can build a building automation system if I have enough help from AI these days, and a little bit of software engineering to make some like really bare bones web apps can go a long ways. I believe it's not quite there yet, but it could be a concept of the future where you could just chat with like something like OpenClaw, and it could just make you a supervisory level controller in the field and then maintain its own code bases. That's, I think, like what people want to be doing. There's also people playing around with OpenClaw. Speaking of which, I'll get back to this. So they're playing around with Open-FDD, where you can pip install from PyPy, which is the package manager for Python. You can pull down the expression Rule Cookbook and do some pretty cool stuff with Pandas DataFrames. So you could instruct OpenClaw to pip install Open-FDD in the field, start scraping data with Python BACnet stack scripts or whatever, just have it make something, and then have it make its own dashboard, and then have it maintain its own code bases, and then a human would be in the loop to validate that it has good data or bad data, that it's actually doing what it needs to be doing. But the idea is like it's maintaining its own dashboard, it's maintaining its own code, so there are people playing around with that I'm real curious to get feedback with. I even have a prompt to play around with that. I don't have like a good real building to play with to do that, but some people are. So I haven't really heard if they're getting good results or not. But so this little thing that I'm playing around with here is not that. Like, I'm actually in, I'll just look at this now. So like if we're looking at a schematic of a building, this is like a little server, and then like I'm bulk loading data onto this little server, and then I'm using some kind of internal AI process inside of this that's just helping me clean data built into Open-FDD. So it's I'm kind of just this project has gone a lot of different directions, but basically this tool could be used to pull in a lot of data from a lot of different buildings, and then using some internal AI agent, something inspired by OpenClaw, to kind of help the analyst process a lot of data at once. It's mostly almost doing this kind of stuff over here, rather than being something that runs on the building, inside the building on the firewall. Originally, I was kind of thinking that this would be cool to do heavy web application, time series databases, Docker. So like anything inside the building that people are experimenting with Open-FDD at the moment is like really stripped down to just none of this. It should just be an image of OpenClaw, and then Pandas DataFrames only, and then it's building its own thing. Who knows what it's building? And then this is, I'm more like on here playing around with if I could export mass amounts of data or pull it down from Onboarddata IO or ASIOT or normal framework or some other vendor. If I can pull data into my own little server or my own, something locally, then I can start running the analytics across the data. But at the moment, this image will get updated. I apologize I didn't do that. So it's getting dumbed down to just OpenClaw and Pandas DataFrames, and who knows if it's even successful yet. I don't know. But at the moment, I'm just demonstrating something that's just to run locally. Okay, so let's get into that. Sorry about that. I was on a rant. So we kind of went through, just to recap, we have a site, testing 1, 2, 3. We did the CSV file import. I'm going to ask AI if it can set up the fault detection YAML files, which you always have you always can do this on your own too. The human can always do this, including the brick modeling. You can export the JSON from the data model. So this is a CSV file. If you look at it, this is a JSON representation in brick format, so supply fan status, and then an external representation of the .feather file. So that's the compiled binary where this is locally on my computer, because it's a desktop application now, no database. Source CSV. So like if you pull data out of the feather, it'll still be in a CSV representation. And then here's also a prompt that you can just plop into ChatGPT, and it'll return all tagged, all the data is tagged and everything. And it can also make all of the YAML files for you. The newest version of ChatGPT is pretty cool. It can send you a zip file of all of here's your JSON tagged with brick classes, here's all your YAML files, and you just chat with it maybe a little bit, and then you just go to this import tab, and you import the process data JSON file, and you import it, and then it'll populate the data model again. So I'm just going to run down to here. So okay, so if I go into plots, as you can see, if I try to plot one of these, load, it's not going to be able to plot. This is Plotly right here, a JavaScript library. If I view the data, it's actually giving me all of the data, but it's still messy right here. Okay, so I'm going to go to this Codex place. So I have Codex built into here. I'm already signed into Codex, so like there's just a button here that lets you sign into Codex, which is actually just 3 lines of code there's a JavaScript library, the npm, which is also the same thing that OpenClaw uses to authenticate with Codex. So Codex is part of your OpenAI subscription. So this is OpenAI. It's part of OpenAI, ChatGPT, and it's included with your $20 a month normal ChatGPT subscription. You get some Codex subscriptions with that too, but you just have to maintain. There's a 5-hour rate limit usage, and then you can only do a weekly usage too. So I'm definitely burning through this quite fast, but let's play around with it. Okay, so this is some previous chats I've had with the Codex. So this is a Codex agent running internally inside Open-FDD. So I'm just going to ask it, can you see this new data set I have for an VAV-AHU unit? Okay, so I'm just going to ask it if it can see it. So hopefully you guys can see this, but Codex is running down here. This is kind of cool. This is all built in React. This chat interface here, so you can see a little bit like what it's trying to do behind the scenes. And then also the AI agent also has model context server, so it can view all of the documentation. So all of this documentation for Open-FDD, it can view all this as well through model context server. Yes, okay, I can see it. Yep, it sees testing 1, 2, 3. It contains 15 data points. Let's call this McDonough HSHU2. Awesome. So okay, so like also previewed. Dataset currently has embedded values with kind of nasty stuff in there. So I'm gonna ask it to, can you clean the data, and also, so I'm gonna ask it to do a whole bunch of things. Can you clean the data, make a nice FDD suite from the expression Rule Cookbook for a typical HU system that is variable volume, and also do the AI assisted data modeling as well, please. Okay, so there we go. Let's see if it can do all this. I think it should. Knock on wood here. This is something I just have working as of this morning, so, but it'll improve. So I also can think of some ideas that I want to build off of well with just like being more inspired by OpenClaw, but just making it kind of hard coded for Open-FDD. Is like we can totally tailor it to specific context. Like you're in fault detection helper, you're a HVAC health expert, you're a mechanical engineer expert, you data cleaning expert. So I'm just totally want to tailor it just for that. And then this is also something, it's just a desktop application. You can shut it down too. So I actually run it through a PowerShell script where it opens 3 different PowerShell windows. And then you can just turn it right off when you're not using it anymore. I've noticed that people that use OpenClaw and Codex, like it'll start doing things in the middle of the night. Like it'll drain your usage overnight, and it's not even doing anything. So like OpenClaw has like tons of things built into it, including it can wake itself up on a cron task, it's called. So it can be doing things in the middle of the night, and people are using it to check their Twitter feeds, or whatever is the neatest app on hackernews.com, whatever. It can follow important people. So the AI agent in OpenClaw can wake itself up, which is something kind of new to the AI world, that like AI coding agents like in Claude or Cursor, they don't have the ability to wake themselves up to do tasks and to remember. So that is a cool thing. And that could also be useful in the smart building industry if you had massive, let's say you have 100 buildings that the analyst is responsible for monitoring. And if you had an enormous Codex or OpenAI subscription, I'm sure this will change. This is just the easiest thing at the moment. That is, you don't have to use an API key. You can just use a subscription, which is really cool. And I'm sure it'll shift to running local models at some point in time. But where's I going with this thought? Like if you had 100 buildings and hundreds of air handling units and lots of mechanical systems that you're watching, maybe having some kind of agent suite, multi-agents watching the fault detections and data modeling and HVAC health and reporting, that it could help you. But at the moment, this is just running, one little task. So it's something that could be built out for that. Done. Okay, wow, cool. I cleaned the metrics, data plots. Okay, so it's 1 point is not plot worthy. Wow, okay, cool. So it already ran fault detection across this. So interesting. So it picked it picked a sensor bounce fault, flatline fault, supplier tracking fault, simultaneous heating and cooling fault, static pressure low at fan full. So okay, so this is where you would have to, wow, it even gave me a link. Curious. Okay, so like I think it thinks it can give me links, but I would have to go back here and plot. Let's make some plots and see if we can actually plot this. See what this does. Okay, load plot. All right, so I can plot data. So it did successfully clean the data. Yeah, cool. If you remember, like it picked out all of like it cleaned all that stuff, which is really cool. That would take, depending on like how nasty the data is, someone could take them a day, an analyst half day, a day, to clean a really nasty data set, especially if it's new and it's not one they're used to working with. And now I can see plots. So here's a mixed air temperature sensor, outside air temperature sensor, and okay, so then what it's supposed to do under the hood too is it's supposed to automatically backfill the time. So that was 90 days worth of data. If you can see that on 50-minute, yeah, maybe that's right. So that's seems a lot longer than 90 days. So this is June 2026, June, and then it looks like it goes all the way back to December, around Christmas. Maybe that's 90 days, I don't know. Okay, so then here's all the fault rules that it created. Okay, let's just, I guess we can just load all of them. Okay, so then we can refresh our chart with fault rules. So this is something that I still need to put a little bit of effort into validating that. You'd really want to validate like that that the AI is picking good faults for one thing, which I think to do okay, and then you could even ask it to add more faults, change the tuning. So like as you can see, there could be tons of false positives. Supplier tracking fault. Okay, so this is just one example. Economizer not using cool OA fault. If we wanted to view that, you could go back to the fault detection rule, and then you can go to select that. So let's see what that is. So AI made this. Description: outside air is cooler than return air, and cooling is active, but outdoor air damper remains minimum. Okay, so it's basically telling us that the AI shouldn't be using mechanical cooling. You could use free cooling. And then this is the expression that AI made this without any direction from us, so then we would have to kind of validate it. This is where the fault detection engineer still needs to be part of the what's going on. But as you can see, it really expedited. As I made this YouTube video, it did all this for us, where this could take me 2-3 days, and it took 20 minutes. So that's the kind of thing. You're still meant for the same person doing fault detection and generating all of the good data insights, but it's actually making them better, faster, stronger. So then these are all of the metrics, which we would have to validate. That the cooling valve is open 15%, that the minimum outside air damper is open 30%. I have to see what that means. But then there's a feature called rolling window. And then if you look up in the documents, rolling window means that since this data is on 15-minute intervals, that 4 of those timestamps would need to elapse before we start triggering a real fault. So basically an hour's worth of data needs to expire before this expression really becomes true. Cool. And then that's how you would tune fault detection. So like we could really look at this information, and then we could be chatting with the built-in Codex Open-FDD AI agent to tune yourself. I think we could have a debate with it. Maybe we should do that now. Do you think any of the fault rules need tuning? All right, so we're going to ask it. Codex is running down here. It does save a little bit of chat history under the hood as well. Then these will be future tabs. Don't know where to take some of these. I do have some inspiration from some other projects to do a little bit of machine learning fault detection, perhaps combine those with rule-based fault detection. So you could run machine learning fault detection algorithms with rule-based and then compare the results. That's a concept for another day. And then perhaps maybe some of this energy in analytics could be something too, where I think a lot of these fault detection platforms have some component of, if it is like a fault, like causing a really big energy penalty for the building, that you can calculate what are the elapsed kilowatt hours or units of gas and therms, and then someone can equate that to a dollar figure. So this is kind of gets into the nitty-gritty of putting an energy penalty calculation to it, which I'm debating about leaving that in here or not. But maybe someone can post a comment if you think that would be cool as well, to be able to chat with, if you can chat with this and then debate with the AI that You know, this could be simultaneous heating and cooling is happening. And then if there's some mechanical engineers that are really good at the energy calculations, that they could be chat with the AI. Here's the rate structure. Here's the kilowatt hour costs for weekends and weekdays. Let's convert that to units of energy, and then attempt to put a dollar figure to it. You know, I think you could do that through chatting with the AI, and then that person really needs to have their expertise in, if they had a career already in, a lot of mechanical engineers do, in calculations. I have a teeny bit of experience of this. That's not really my expertise. My expertise is more on finding the faults in the building automation, and I can do these, but some people have spent their whole career in energy engineering, so they could really debate with the AI and be like, yes, this is good numbers or bad numbers. So I have the certified energy manager, and also a certified measurement verification professional. But some people have spent their whole career doing nothing but energy calcs day in, day out, which I have not. But yeah, it's cool. So I'm actually happy with where this is today. I'm hoping to demonstrate soon more data sources, so we could get data from OpenMedio, which is a free weather API. So for this McDonough site, I could actually download historical web data, and then we could compare it to local building automation center data, and then find where the flaky building automation center data is needs to be improved, which can make a big difference in how the mechanical system operates. A future backnet driver, and then also Onboarddata. That's my next thing. So I have all the scripts made to test and scrape the onboard sample buildings, sandbox buildings. So it's actually right here. So Onboarddata, this is my next big thing. I'm going to try and do this maybe next weekend's vibe code. Next weekend's OpenAI and Open-FDD, just to show you where I'm at with the project. Maybe I'll have this ready, and we can pull in a sandbox building with Onboarddata. So yeah, this is really cool. So this is really cool. I'm so glad that these guys did this. Free member, so you can get. I've signed up for this. I have scripts that can query the API and pull the data. I just have to build it into Open-FDD still, so I'm still working on that. But this is really cool that they have just a random, anonymous building. I think there's two actually. One I noticed is a sandbox building in New York City. So I know I can query the data and then do another bulk data import, and then I'll repeat this process again. Do the AI assisted data modeling and then plotting, and then watch the heck out of my cursor use or my Codex usage, because it drains it. And then yeah, this is cool. I'm excited. So I'll be playing around with this pretty heavily, and then we can do use Onboarddata, and then hopefully we can build more drivers out for other normal framework. Would be really cool to play around with, because they have an API just like this too, perhaps ACE-IoT, so and the more people the better. This is a free tool, community-based tool is what I'm going for right at the moment, just to be a standalone analyst tool where they can just the analyst can do work really fast and efficiently. So this is just a start, so lots of cool stuff to come here. So thanks for following along. It's a long video here, so hope you enjoy the rest of your weekend, and catch you on the next one.